Hey everyone, this is Matt with Learn Everything About Design, and in today's video, we're going to be making this print-in-place sphere. Now, I've had a lot of requests for more 3D printing content in Plasticity, and this is a fairly simple model that even a very beginner to Plasticity should be able to create. So if you're looking for things to design for 3D printing, then this video is for you. Make sure that you remember if you're trying to buy Plasticity, we are an affiliate. You can use the code LEAD10 at checkout, and that will save you 10% off. So let's get started and talk about what we're going to do. So we're going to start a new file. We're going to select and delete the cube with the delete key and hit the / to zoom in. Whenever I'm designing for 3D printing, I always make sure to go into my preferences and grids and units and set up a grid size that makes sense for my 3D printer. Now I'm using a K1 Max and the build size is bigger than 250 by 250, but this gives me a good idea on the overall size that I have to work with. Now, I strongly suggest that if you're building for a 3D printing setup, then make sure that you use a grid size that is at least undersized or if not the exact size as your build plate. So with that set up, what we're going to do is going to hop in and use some very basic tools. If you have never used Plasticity before, never opened the software before, you're probably going to have some difficulty following along, but we'll call out where everything is. But I do suggest that you check out our Getting Started content or our UI overview, where we talk more about the user interface. And we've also got a series on basic workflow in Plasticity, and we have a course on our website, learneverythingaboutdesign.com. But to get started, let's just make sure that we understand some of the basics. We've got curves on the right-hand side that are used to define close profiles that we can turn into things like extruded solids. We've also got some primitives, which are going to be the main focus of what we're doing here. So we're going to focus on the sphere primitive for this video, as well as the line tool, and those are pretty much the main two tools that we're going to be using from over here. We'll start with a sphere, and we'll select the origin and begin dragging this out. Now, for my example, I'm going to make one that's 50 millimeters. So I'm going to hit Tab on the keyboard and just type in 50 and hit Enter twice. Now that we've got a 50 millimeter sphere that's centered at the origin, I want to move it up so that the bottom of it is going to be on my XY plane. If you're on a laptop and you don't have access to the numpads, then you want to use the view cube in the right-hand side and just simply click on the XZ face, and that'll go to a front view. You can also use the numpad number 1 to get to your front view. With the object still selected, we're going to use the move command, which is G on the keyboard. And once we activate the move command, the bottom right will show us a handful of options that we have. In this case, we're going to hit Z, which will lock the object to our cursor in the Z direction. I'm going to move it till I feel like it's about where I want it relative to that red X-axis line. It looks like about 15 millimeters, so then I'm going to manually enter 15 and hit Enter twice to accept. While we're still on this front view, we're looking at this sort of orthographic plane, the front plane. We're going to use the line tool, and we're going to draw a line on the X-axis, right-click to accept. From here, we can rotate it around if we want, and now what we're going to do is we're going to use this as a cutting tool. A lot of times when you look at the bottom, we've got some default tools that'll stay in the bottom left. And you'll notice that here we've got cut solids with curve. This one should always remain here, but you can use the shortcut key C as well. We're going to click on that, and then we're going to select our object, and then we're going to right-click to accept. If you do this while still looking at it from the front view, it should select the bottom portion of the sphere. If you're doing it from an isometric view, then likely it's going to select the top. So what we want to do is select the line and hit Delete or X, and select the bottom part of the sphere and hit Delete. Then we can hit the / to zoom back in. So now we've got the overall shape, the basic shape of the thing that we want to make. What we're going to do from here is make a duplicate of it, because when I'm working on print in place models, I want to see the inside or a section of the object I'm working with. And we don't have a temporary section view that we have, at least that I'm aware of in Plasticity. So the way that I do this is by selecting the solid and duplicating it. Again, we've got shortcut keys Shift and D if you want, but we can click Duplicate Object and then right-click to just place it exactly where it is. And then we're going to hide the original solid by clicking on the eye icon. From here, we want to go to a top view, which you can do with 7 on the numpad, or you can click up here, / to zoom to fit, and then use our line tool once again to create a cutting tool. Right-click to accept, and again, we can use the cutting tool with a shortcut key C, or click here. Select our object, right-click to accept, Then select the front and delete with the delete key or X on the keyboard. So now we're going to rotate back around, and we've got our section view of our object. And the reason this is important is because, again, when we're modeling for things that are print in place, we need to be very specific about things like gaps and angles. And being able to see inside the model in a section view, at least for myself, really helps me visually. So before I rotate this back to a front view, I'm going to select this edge and I'm going to duplicate it. Now you can do Shift D on the keyboard to duplicate the object. It's not going to show up here because currently with an edge selected, it's defaulting to this fillet tool. So in order to select that, you'll have to hit Escape first, and then you can do a duplicate, or you can hit Shift D. We're going to right click, and we're going to do the same thing on that bottom edge. Shift D, right click. The reason I did this with two separate instances is because I wanted these curves to be separate and not joined together. Now I'm going to go back to my front view, and we can begin modeling all the information we need to cut the original solid sphere. So if you are new to 3D printing, there are going to be a couple things that you should understand. First, we're using desktop filament style machines, FDM or FFF, fused filament fabrication, and these use a spool of material that gets melted and built up in layers. When we're building up in layers, and you don't have to follow along with this part here, but when we're building up in layers, going up vertically is no problem at all. If we are rotating at an angle that gets below 45 degrees, then oftentimes we start to have issues. Now, most printers on the market today will support anywhere from 49 to 50 degrees without needing support material. For our purposes, we're going to stick to that 45 degree number. So basically what happens is if we start to build too steep of an angle or too much close to a horizontal line, then as the 3D printer builds up those extra layers, we're not able to have anything to build on top of. It gets to be too steep. In addition to this problem, when we're printing something like a sphere, the section here in the middle where it's near vertical prints pretty well. We'll get really good resolution on our parts. But as we get closer to the upper section where the travel is more in the horizontal direction than the vertical direction, we run into that same issue. Now, it's not an issue where we can't support the material, but the resolution that we're going to see with a relatively small sphere, in this case 50 millimeters, you're going to start to see some inconsistencies, especially right at the top where it's near horizontal. To get around this, we can add some additional features like a divot or a dent in the top, and that'll help hide some of these problems. But just keep in mind that there are going to be some limitations, especially when using curvy parts. So now that we've got all that out of the way, let's go ahead and add a horizontal line from the origin and just make sure that it comes out past the entire sphere. Right click to accept. With it still highlighted, we're going to use the rectangular array tool, and we want to come up vertically. You'll notice there's a red line on the screen. This is a projection from the midpoint of our selected line, and this helps us ensure that these lines are vertical relative to each other. They don't actually have to be in this case, but it does help. And then we need to decide where we want to split this object up. So I'm going to just put it about here. It looks like about 25 millimeters. I'm going to use 3 individual instances and then right click to accept. The bottom line isn't needed because we already have a bottom line here, so we can delete those. And then we can use the trim tool to trim away this excess and right click to accept. The main reason we're doing this is because we're just interested in this point and this point. We want to find out where these points intersect the overall sphere shape, and that's where we want our divisions to come from. So I'm going to zoom in a little bit, and I'm going to use my line tool starting from here. And notice that when I go down, the angle displayed on the screen is 90 degrees. Remember, we want 45 degrees, but if we hit a value of 45 degrees, we're going in the wrong direction. So I'm going to bring this line all the way down to here. I'm going to hit tab until I get over to the angle, and I'm going to say 90 plus 45 and right click to accept. Notice that the endpoint is not snapped to this line anymore, and that's fine because we actually don't want it to be. What we want is we want to come from this section here, and when I say this section, we want that horizontal line. This is going to be what's adhered to our build plate, and then we want to come up to this line. We can't go up vertically because then this portion of the 3D print would just fall off. So it has to hook inwards, and we want to think about our angles again. It doesn't have to be 45, but it needs to be at least 45 or steeper. If you're not sure about these snaps, what you can do is you can always extend the lines and we can trim them later. So again, we want to do 90 plus 45 and kind of see where that leaves us. It looks okay. And then we'll hit enter to accept. Then we'll use trim and we'll trim away these sections and right click to accept. Now we need to join these together. And the join tool is this circle icon with the plus in the center. That can be used to join sheets or surfaces together, but also curves. And the main reason that we need to do this is so we can fill it or round that corner. So we'll click that or hit J on the keyboard. And now you can see that that vertice turned to purple. With that, we can now add a fillet to it. And this is a B on the keyboard, or you can select this object right here, this icon. And then we'll pull this out and notice that it's creating a flat. This is going to be a chamfer. And if we pull it the other direction, that's going to create a rounded section or a fillet. I'm going to go to about 2.5 millimeters, doesn't need to be specific, and then right click. With this line still selected, we now want to offset it. The offset tool, if you look down here, we've got things like move, rotate, and scale, and then some Boolean options which let us join solids together, cut, mirror, and duplicate. Now, if we go over to the right-hand side, all of these tools are contextual. And what that means is these are only going to appear based on our current selection. What we want here is this one called offset curve, or it's O on the keyboard. As we pull this out, you can see that we're creating a variation or an offset of that original selected curve. This number is going to be critical for us. We want to make sure that we have a 0.4 millimeter gap, so we want to manually enter 0.4. The reason that we want a 0.4 millimeter gap is because this is going to be big enough that we can print these parts in place, and they're not going to stick together, but they will be loose enough that we can rotate them freely. We can go tighter than this if your printer will support it and you've got good resolution. You could go down to, say, 0.2 millimeters, but honestly, you're probably asking for a little bit of trouble if you go down that far. The next thing that we want to do is we want to extend this out. So there are a couple ways that we can do this, but honestly, if you're a new user, the easiest thing for you to do is probably just add another line. And then when we're here, we want to tap the Shift key. And what that'll allow us to do is have this projection here. You can just extend it past, or you can tap this curve and hit the Shift key again. And that will allow us to find the intersection between those two. Again, as a new user, I would probably suggest just extending it out with a new line and then using your trim tool to cut it back. It just makes it a little bit easier. I'm going to hit Escape. I'm going to delete this line, and then I'm going to Shift select these. And notice that I still need to trim that down there. Let's go ahead and trim this one first and right click to accept. So at this point, what we want to do is, I'm going to go / so it's zoomed out. What we're doing is this is that bottom section of this sphere. Basically, we could move this out further. We could change the angles. Again, depending on your printer, 45 to 50 degrees is generally okay and accepted. And 0.4 millimeters is about a good gap to allow us to build these parts. But we're going to repeat that same exact process coming up here. And now I'm going to come down to this line and tap Shift. That's going to give me this projection. And basically what I'm going to do is just draw a line out here, right click to accept. And I'm going to do the same thing down here. Figure out about where I want it, come over to this line and tap Shift, and that'll give me that projection. Then I can use my trim tool, right click to accept, Shift select those, join them together, and then use fillet or B on the keyboard, and then round that off. And once I have this, again, we want to offset, which can be O on the keyboard, or click this tool right here. We can offset it inward or outward. It really doesn't matter, but it does need to be a good number, so 0.4 millimeters. If you go bigger than that, then again, you're probably asking for trouble. They're going to be pretty sloppy. If you go smaller than that, then likely you're going to run into some issues as well, because it might be too tight and it might not actually stick. Let's go ahead and join these together. Again, J on the keyboard or click that. And then we're going to use our trim tool. We're going to trim this upper and lower section, move our way down, trim that, move our way down, trim this, and trim that. We want to get rid of that line, delete, and then what I'm going to do is I want to grab everything here and join it together. So grab this bottom edge, shift select, zoom in, shift select, join it together, J on the keyboard, and we'll do the same thing here. Grab everything, work your way down, and click here or J on the keyboard. So now what we've created is two closed profiles. Now I could just spin these around and cut them away from my solid at the same time, but just for some practice, I want to do this without cutting it. So I'm going to select this profile, and I'm going to select this profile, and what we're going to do is we're going to revolve them. So we're going to pick the revolve tool. I'm going to select the y-axis and then select it again and right click, and notice that now I have these two revolved solids. I'm going to hide the curves because I don't need to see them anymore. And just for practice, I'm going to bring back my sectioned view, and I'm going to select that object. And what we're going to do is use the Boolean tool. Now, Boolean allows us to cut away from a solid or join multiple solids together or keep the intersection between them. And in this case, what we want to do is select one of these and then hold down the Shift key and select the other and make sure that we're keeping the tools. And the main reason we're keeping the tools is because we need to do this again to the other solid. So if we hide the revolve, let's go ahead and hide these and bring back the original solid so you can see we've got that, and that. And essentially this is what we're building. This is going to be stuck to the build plate, and it's going to go up at a 45-degree angle and back out. And when this prints, this piece can't go up any higher and it can't go lower. So if we were to think about this and use G to move it, you don't have to follow this part, but as I move it down, it's going to physically hit and stop. It's not going to allow it to go any further. And same thing in the vertical direction. It can't go past that other solid. So this is exactly what we want. I don't really need these solids, but I'm going to keep them around just to show you a couple of other things. So we're going to repeat the process. Q on the keyboard or select Boolean. Then the tools are going to be this and this. Hold down Shift. I don't need to keep the tools anymore. I can right click and allow them to be removed. If I hide one of these center sections, you can do that with the eyeball or H on the keyboard. You can see what we're left with here. So before I get too much further, I want to actually add a small chamfer to these edges. So I'm going to select an edge and begin pulling it to add a chamfer. And then I'm going to hold down Control to select another edge and do the same thing down here. And basically what I'm doing is just breaking those edges so that it's a little bit easier once we print these parts. It'll help us to just begin to spin them right away. If we leave those sharp edges on, oftentimes you end up with some print issues that happen right on those corners. Adding this small bevel here or the small chamfer creates a little bit of a flat spot there, and that allows us to get one or two traces around without needing that point. So that looks pretty good. Right click to accept, go back to a front view, and then we're going to actually rotate around a little bit. Then what we're going to do is use our sphere tool again on the bottom and make about a 14 or 15 millimeter sphere. Right click to accept, and notice that cut away from our the bottom of our part. Now, if you didn't mean to cut away, there's no history, so we need to use Control Z and undo. And the one thing to pay close attention to here is when you snap to other geometry, oftentimes it's going to default to cutting that away. Even if the preview doesn't show it, it's always a good idea to hit B for new body, just to make sure that you are creating a new body. So I'm going to go back to a front view. I'm going to use my Move tool, and I'm going to move this in X and Z. Now, typically I would use the shortcut keys, just hit X and hit Z and play around with it. But the main thing that we want to focus on is we don't want this to overlap these internal edges. And this is the main reason that I kept the original solid. So if I hide this and I bring back, let's see, this one here. So this is my sort of section view. We want to make sure that this sphere does not overlap this. And that's kind of important because then we're going to have discontinuity. These pieces aren't going to be connected. So just make sure that you do double check this when you're playing around with it. And let's go ahead and bring that solid back. So now we're going to use Boolean again. Select this bottom object. This time we're cutting away the sphere. And with the new edition of 24.2, the latest release, we can now select that face. We can hit F on the keyboard to find and start to type in array. And we can do a radial array of that face. We're going to select the Z-axis, I'm going to add, let's say 8 looks okay. And you can see we're able to do a radial array of that. For now, I'm going to delete the 3 other solids because it's just going to complicate things. And then I'm going to hide this one here, and I'm going to focus on the next one. So I'm going to use the same trick, sphere, and let's say about 14, 15, B on the keyboard to create a new body. And then I'm going to go to my front view. We're going to move it with G. I'm going to move it up in the Z direction first, and then in the X direction. And we want to get to a position where we can use it as a cut tool. That looks pretty good. Now, I'm using spheres in this example. You could do whatever you want to add a pattern to this. Sphere is just generally easy because there's a primitive for it. But if you want to use something else, then by all means explore that. Once again, Boolean, select that face, F to find, and type array. We're going to do a radial array. We'll select the Z-axis. I'll use 8 again. And then we can hide this one. So that's H on the keyboard, or click on that eyeball icon. Now, this last one is something that we need to pay close attention to make sure that this center section isn't too small. But we're going to use that same sort of trick here. We're going to do a sphere on the bottom. I can make this one a little bigger or smaller. But again, B to create a new body. We'll go to our front view. We're going to go G and Z, which is our move tool. And again, this is the little trick. If we get rid of a portion of that in the top, it'll help us hide some of those potential issues. So I'm going to right click to accept. I'm going to duplicate it. I'm going to move the duplicate over here, maybe pull it down a little bit, and accept. So I'm going to delete the first one, or get rid of the first one with the Boolean tool. And then I'm going to repeat that process, getting rid of this one, and then F, start to type in array, and select the Z-axis. It looks like 8 might be too much for this. I'm going to take it down to 6. There we go. You can also add a small chamfer to the top of this, or a fillet if you want to. Chamfers are generally better for 3D printing. But now we've got our print in place fidget sphere. So of course, you can add as little or as much detail to the outside of these things. The little divots using the sphere are pretty nice because you can get your fingers in them and you can turn these things. Again, you can add any kind of detail that you want. If you want to add lines or recesses or text around the outside, you can create, some sort of little decoder where different letters line up at different points. But once you have all of this, then all we really need to do is select export. You need to pick your file type, OBJ or STL. Most 3D print slicers will support STEP. So it just kind of depends on what slicer you're using. I'm going to pick STL, and I'm going to call this just sphere video. And then we need to look at our settings here. The density is going to be important because if it's too low, then the sphere itself is going to be pretty faceted when we go to create a 3D print of it. And remember, in the XY direction, we actually have pretty good curvature. 3D printers, in most cases, will be using an XY travel, so you will get a bunch of straight lines. Most of the newer printers and the firmware in them will actually support true arc movements. So if you are using a step file instead of a mesh, and in some cases a mesh file, it's actually able to interpolate that. If you are using a step file, then you may get an actual G2 or G3 arc movement in the code. But for the most part, we do want to make sure that our density is high enough that we've got good resolution on the outside. It doesn't necessarily have to be cranked up here, but for the most part, we want that. And then we just need to go to our 3D print slicer. So once I got my print slicer open, all I need to do is navigate to the file, and then we'll open it. So the main thing that we want to look at here is when we're slicing, I don't have any supports turned on. And if you do turn on supports, you might find that it's trying to put some in these little divots or spheres here. But the main thing that we want to do is follow this down and just make sure that there is a clear division between the different layers. So you can see here, this is the inner layer. And when we look at the traces, there is a clear gap between the outer walls, which are displayed in red in this slicer. And you can see here, The outer walls, the inner wall is green, and then the infill is yellow. So we want to make sure that there is a clear gap here. Now on my printer, I've gotten away with as low as 0.2 millimeters for the gap and still had print in place parts work. 0.4 seems to be pretty common across the board. I haven't had any problems with that. If I've gone bigger than that, if I've gone to 0.5 or more, generally we start to see some issues. I would suggest with most 3D printers that if you're using a 0.4 millimeter nozzle, that you think about these in terms of some sort of multiple of that number. So 0.2, 0.4, 0.6, 0.8. If you start to go to like a 0.5 or a 0.7, things get a little weird. So just make sure you play around with it and view it in your print slicer, because that'll be the final test as to what you're actually going to get. Now this is a slightly different variation than the one I just printed, but for the most part, the process is the same. And the general rules are going to apply across the board. Whenever you're modeling something in Plasticity or any software, you need to think about the overall scope of your project and any specifics that you have to have. In this case, the main criteria here was making sure that it fit inside the 3D printer, which is not a problem at this size. And then also making sure that we were adhering to specific angles that we could print unsupported, and that also we were looking at a gap value that worked, in this case 0.4 millimeters. So with just a couple of those little criteria, those little pieces of information, we're able to just explore the design. Now, I've printed probably 6 or 7 of these different things, designed in Plasticity as well as in other software, with all sorts of different variations to the geometry on the outside. The sphere as a cut tool is one of the easier ones to grab onto and hold, but you could do whatever you wanted to make these things unique. Now, if you do decide to do something with this, leave a comment, let me know what you're doing. And if you want to see more, then leave that in the comments as well. I have a pretty long list of videos that people want to see in Plasticity, from car parts based on scans to 3D printed fidget cone I did in Fusion. And I've also got a couple of video requests for things like storage trays and how to break up 3D printed parts so that they'll lock and fit back together. So there's quite a big list of things that we need to do in Plasticity, and we will get to all that as soon as we can. But if you have any other comments, questions, or suggestions, please leave them under this video. Remember that we are an affiliate, so if you're purchasing Lead 10 at checkout, we'll save you 10% and it will help out the channel. And as always, thanks for watching. We'll see you in the next one.